end of the developer?
I've heard that before.
Hi there, Lorraine. What you doing?
Oh, you know, organizing yesterday's program cards, which got dropped, figuring out why the machine keeps stopping on card 4042, logging this really awkward bug in the Vogels compiler, and talking to you. Anything new at head office?
I've been reading about this, COBOL?
Yes, it's the new high-level language.
It's amazing. Now anyone can write code.
I don't know about anyone. Writing software is pretty tricky.
Soft. What?
Software.
Where? Hey, Marty. What you reading?
Just learning some VB.
Visual programming, huh? Coding's history, Marty. Drag and drop is the future.
Drag and drop is still code. It still has bugs, and it still needs an engineer.
Everything fails all the time.
Is this for real? Could cloud mean there will be less engineers?
Less engineers. Time for an airdrop.
Servers in minutes? Scale on demand? Pay as you go? Wow. You learn something new every day.
You build it, you run it.
Mom?
Oh, sweetie, don't forget to call Mom.
Why, hey there, Marty. It's a nice wormhole, isn't it? Mind if I join you?
Oi, you can skip this one.
Is this the end of development as we know it?
Or is it just another new beginning?
Please welcome the Vice President and CTO of Amazon.com, Dr. Werner Vogels.
Thank you. Okay. Trust I seek and I find in you something new for us every day for us something new, an open mind for a different view, and nothing else matters. Good morning. Oh, no, it's not. Hello, guys. So the video showed you every generation of developers that faced a new wave of change. Yeah. Tools evolve, architectures evolve, expectations evolve, and so do we. But before we talk about that, let's talk about the elephant in the room. Yeah? I've been giving this keynote since 2012, and I've done all of them. That's a lot of t-shirts, by the way. Yeah? But today, this streak ends. This is my final reInvent keynote. Yeah. I have still things to do. I'm not leaving Amazon or anything like that, but I think that after 14 of reInvents, you guys are owned young, fresh, new voices. There are so many amazing engineers at Amazon that have great stories to tell, to teach, to help you, to educate you. And I think it's time for those younger, different voices of AWS to be in front of you. By the way, nobody forces me to do this. I'm not leaving Amazon or anything like this. This is my decision to make sure that you get to hear different voices than just mine. Now let's talk about the other elephant in the room. Yeah. I visited AWS customers all over the world. And there is these days one question that keeps coming up in every country and in every city. Will AI take my job? Maybe. Yeah? Our roles transform. Some tasks will be automated. Some skills will become obsolete. New ones will emerge. So maybe we should rephrase and reframe this question. Yeah? Will AI make me obsolete? Absolutely not. Yeah? If you evolve. Yeah? And if I look at the past years at Amazon, where we've been using all these new tools, we've seen how you can evolve over time and still be a great engineer with just a new set of tools in your hands. Because we evolve as developers. Yeah? And so must our tools. And so change is constant. And this has always been the case. It's nothing new. Yeah? Here, let's go back in time a little bit. Just for the heck. When I went to school, I was taught 68,000 assembler, COBOL, and Pascal. Yeah? None of these languages are being used anymore. And in the 60s, we suddenly got compilers, and it didn't really matter anymore what kind of assembly those compilers spit out. However, by learning assembly, I learned how that loop in Pascal actually translated into machine code. And so that was important to me. And over time, compilers became the highest level abstractions that most developers needed. In the 70s, suddenly structured programming became popular. Yeah? And we're moving towards that. Compilers out of Bell Labs and Berkeley, they supported this shift. They give developers a clearer control over flow and help them escape the chaos of unstructured code. And then a few years later, Werner he started exploring how to model real-world concepts directly into coding, objects and classes. And that became C++ and helped shape object-oriented programming. In late 1990s, Amazon was still running as a monolith. And in '98, and this is this famous moment, the growth accelerated to such a point that the team began breaking off pieces of this monolith into services. And each service had ownership of their service, had their own interface, and it completely changed how developers worked. They moved faster, they became independent of other teams, they owned their systems end to end. And over time, the industry at large became adopting these kind of practices as a practical model for building and operating large-scale distributed systems. Actually, and what about the tools in those days? Yeah? But in the 2000s, most developers, they were still building and deploying things on-premise. Yeah? And writing code meant wrestling with hardware, capacity planning, long procurement cycles. And when cloud services arrived, they changed the expectation of the role again. Developers suddenly had on-demand infrastructure, freedom to experiment, without waiting for hardware. And this required new skills. And developers everywhere adopted to a world where cloud infrastructure just became the normal way to build and operate software. My first IDE, any guess? VI. No, I'm not an Emacs person. Yeah? Just the same. And the IDEs actually, they evolved with us. We got, Microsoft had some moment, you could actually draw boxes on the screen and you had this first real IDE. And later we got Visual Studio. And then Visual Studio Code became the default because of all the amazing plugins and all of that. And today's environment are Cursor and Kero. And that's the new workflow. Is there a new workflow next year? 5 years from now? 10 years from now? Of course there is. Yeah? Our tools today, though, I think are kind of extraordinary. In Matt's keynote, we already saw examples of developers becoming dramatically more productive with AI-assisted workflows. But none of this removes the work that only you can do. Remember, the work is yours, not that of the tools. It is your work that matters. Yeah? Our tools have changed so many times over the course of my career, and they will continue to change. We're still builders. We're still important. Nothing has changed there. There's never been a time to be more excited about being a developer. Bezos, not that long ago in an interview, he talked about this as that we're living at the epicenter of a multiple simultaneous golden ages coming together. Space travel, artificial intelligence, robotics, each are advancing at an incredible pace. But what makes this moment different is how these breakthroughs actually reinforce each other. Progress in one field accelerates progress in the other fields. And this actually made me think back in history at a time when that was kind of similar. Yeah. The Renaissance, the rebirth, came after a period of darkness, the Dark Ages, the Middle Ages, the Death Plague. And anyone who knows Monty Python knows about how that looked like. But the Renaissance was a period where everything changed because people became curious. Curiosity was absolutely exploding. And the result of that is amazing scientists and philosophers. And if you look at this, the Medici is probably the first version of a venture capitalist or a philanthropist or whoever you want to name it. Galileo and Copernicus were amazing scientists. Petrarch, one of the first philosophers. Da Vinci, we'll come back to him. But what also evolved at the same time were their tools. It's not just them, because of curiosity. A pencil was invented. That seems nothing to be invented today, but it was a major thing. The fact that they start thinking about something called a vanishing point was suddenly that if you compare paintings and drawings before the Renaissance, they were all flat. In the Renaissance, suddenly depth appeared and different lighting appeared in paintings and drawings. And then these tools like the microscope and the telescope, of course invented by Dutch people. Not saying anything. And then, the printing press, of course, we all see as sort of the pinnacle of invention in the Renaissance. But that was not just one invention. Gutenberg actually used a wine press as his first tape. But that was not the only thing he needed to invent. He needed to invent movable type. Basically, that you have characters that you can put together. He had to invent an ink that actually could be put on those characters. And then paper to press on. Imaginary, almost imaginary in those days. It was a time where art and science were part of the same conversation. Creativity and technology evolved together. I've spent some time to think about what made people so effective in that world. They were curious. They questioned assumptions. They learned broadly and applied that learning deeply. They didn't see boundaries between fields. They built bridges between them. They were also bold experimenters. They sketched, they measured, they failed, they tried again. They learned by doing. So if I take all of that in, I think by putting that together, I think we are again in a time of Renaissance. And you are the new Renaissance developer. Those qualities of those scientists in the Renaissance are just as relevant today. So I've brought them together into a framework that I call the Renaissance developer. And I want to show you today this framework hopefully help you evolve and be successful in this new era as well. What is crucial in all of this is the first quality that you need to nurture is you need to be curious. Curiosity is critical. As developers, you always had to continuously learn because everything changed all the time. And every developer I've met has this instinct to take something apart and then look at how it works. And that's also what drives us here, the desire to understand, to improve, to build. You have to protect that instinct. Stay curious, because curiosity leads to learning and invention. Equally important for learning is two things. Yeah? For all new inventions, you need to experiment. And to experiment well, you need to be willing to fail. After all, Da Vinci modeled an airplane that never flew. But we're flying now. Yeah? And by the way, an experiment is not an experiment if you already know the outcome. Yeah? It drives experimentation, drives to learning. And this willingness to fail is crucial. When I learned a new language, whether that is Dutch or English or Portuguese or German, I find that the same principles apply. The best way to learn is fail and be gently corrected. You can study grammar all you like, but real learning begins when you stumble into a conversation and someone helps you to get it right. Software works the same way. You can read documentation endlessly, but it is the failed builds and the broken assumptions that really teach you how a system behaves. And any of you who have recently used the Rust compiler knows how much feedback you can really get. And there are some things that you can only do and only learn by doing. Reading, watching, listening only takes you so far, but real learning happens when you engage, when there's some pressure, when the outcome matters. There is a relationship between stress and performance called the Jerks-and-Dobson law. The picture is a bell curve. You know, too little pressure and you're disengaged. Too much pressure and you're overwhelmed. The sweet spot is somewhere on that rising slope where curiosity meets challenge. That's when your brain is fully alert, focused, and ready to grow. Yeah? You can't reach that point by sitting comfortably. You have to put yourself in positions that test you. Now, there's a whole story behind this. And that newspaper that you all found on your seats today, the Kernel, there's an article in there by Andy Warfield who writes about this. I urge you all to read that article if you really want to understand more of that. Now, learning, there's another side to it. Learning is social. Yeah? We're not here only to sit in the room and listen to one person telling you exactly what to do. The thing you really learn is by talking to each other. Learning isn't just cognitive, it is social. You have to touch the grass occasionally. And by that I mean, you have to get out of your usual environment. Go to a user group. Attend a conference like reInvent. Have coffee with a friend and talk about systems. One of the best ways to stay sharp is to be around other people who are building things. And for me, that often happens when I'm on the road. I travel a lot for work. And those trips keep me connected to how people are actually using technology, not just how we imagine they might. This year, I was very fortunate. I took 2 month-long trips, one to Africa, Sub-Saharan Africa, and the other to Latin America. In both regions, I gave some talks, but I mostly meet with customers. And the real thing I do is learning from those customers. Here are a few examples. Yeah? Here's Age. This is actually also, it took me 21 years to actually end up on the Amazon. Yeah? And so, Group by Age is a beverage company. They support communities along the Amazon River in a way that they give young people an economic future so that they don't leave their villages to go to the big towns. It is a brilliant experience and a great example of how doing good can be profitable at the same time. The Amazon River was beautiful. I saw pink dolphins. Yeah? But it reminded something else that I learned, that not all of this is so great. Earlier in the year, I spoke with Boyan Slat from the Ocean Cleanup Project during an episode of the Vogels podcast. And he told me that 80% of the plastic found in the ocean originates from just 1,000 of the world's 3 million rivers. To rid the oceans of plastic, they need not only to clean up what is already out there, but also to stop new plastics from entering the ocean via these rivers. And they do that. They've created a river model using drones, AI camera analysis, even GPS-tagged dummy plastic. In the place where we went onto the Amazon in Manaus, they actually took plastics and put GPSs in it, threw it in the river, see where it ended up. Turns out, the Amazon is not a big polluter at all. But this computational model that they've built, these AI cameras that are on bridges, that are on the back of ships, yeah, they create a computational model that predicts how and where this plastic will traffic, and helping them position their cleanup systems for maximum impact. Now, another thing that totally blew me away on this trip was actually in Rwanda. In Rwanda, this is the headquarters of the Ministry of Health. Yeah? And this is their Health Intelligence Center. In their operations centers, huge screens display near real-time data from 4 different tiers of healthcare facilities across the country. They've built an impressive system that ingests and processes vast amount of healthcare data, visualizing everything from disease outbreaks to maternal health outcomes. And they use it to create new policies. Yeah? They've created this model which shows that which parts of the country are more than a 30-minute walk away from a healthcare provider. And they use this data to strategically place new maternal health facilities in underserved areas. They use data to drive policy and to actually implement that policy. Another visit that actually, most of these trips I get blown away every time, especially about how young companies are attacking some of the world's hardest problems. In this case, we're in Nairobi. And I learned that in many places there, people will just borrow $1 or $2 in the morning, buy some goods, go and sell it on the market or on the street, and in the evening they will give these dollars back and hopefully have 40 or 50 cents, which they made that day. And that's enough to go buy some food. Great. It is not enough, though, to also buy the gas to cook your food. So in those poorer parts, it's all burned on carbon, which is massively polluting. So there's this young company called Cocoa Networks. They came up with a completely different solution. They basically built these kind of ATM machines with ethanol in them and a small canister that people have. And they can basically walk up to the ATM, to the machine, plug in their canister, and ask for 5 cents of gas, which will be enough to cook their food that night. Yeah? This is what happens when developers apply their skills to real human challenges. Developers have always driven progress. You have built the foundations of the digital world, and today you're the ones turning to AI from possibility into something useful, safe, and scalable. And developers like you were essential in the past, they're essential today, and you will be essential in the future. The United Nations expects that by 2050 we have 2 billion more people on this planet. How are we going to feed them? How are we going to make sure they have an economic future? How are we going to make sure they have health care? That's on us to develop technologies so that we can help solve some of the world's biggest problems. Us as technologists have that ability to do. And if I look at some of you who spend so much of their time not just to actually build some things in the corner of your room, but actually help others, the AWS heroes. Yeah? We now have 200, yeah, they deserve an applause. Oh, there. So I've met community builders, I've met AWS heroes, and these are people that are solving hard problems in their own corners of their world. There are now 265 heroes across 58 countries. But what constantly amazes me is how much we can learn from them. By the way, this year's Now Go Build Award goes to Raphael Quinsambone. Stand up, Raphael. Rafi absolutely embodies the Renaissance developer. He doesn't just write code. He builds communities. He mentors others, and he co-leads the AWS user group in the Philippines since 2013. Come on, Rafi, one more round of applause for him. So the first quality I think that a Renaissance developer needs to have is to be curious. And I like this quote from Walt Whitman. Yeah? We are not what we know, but what we are willing to learn. Another quality that I think the Renaissance developer has is that he thinks in systems. Yeah, and let me just go with me for a moment. If you don't really understand that, I don't mean the computer system in this case, but in a big system. So in the 70s, an ecologist called Donella Meadows began studying how complex systems behave. She wasn't a computer scientist, but her insights describe our world of software perfectly. And she wrote, yeah, a system is a set of things, people, cells, or whatever, interconnected in such a way that they produce their own patterns of behavior over time. And that was an extraordinary definition because it captured what every engineer eventually learns, that our systems have lives of their own. Let me give you an example, by the way, that is not computer related. One of the most striking examples of systems comes from ecology. In the early 20th century, the wolves were removed from Yellowstone National Park. It seems logical. Yeah? Fewer predators meant more elk, meant more life. Yeah? But the opposite happened. The valleys were overgrazed, the trees disappeared, the rivers began to erode, and this phenomenon is called the trophic cascade. When we reintroduced in 2010 wolves back into the park, slowly the park started to heal. Vegetation returned, beavers came back, even rivers changed course. The wolves didn't move the rivers. Yeah? They changed the behavior of the overall system. That single feedback loop, predator and prey, reshaped the balance of the entire system. And when structure changes, behavior changes. And when feedback changes, outcome changes. That's what's called systems thinking. So when thinking in systems, we think in complete systems, not just in isolated parts. Every service, every API, every queue is part of a larger system. You can't change one part in isolation. Alter a retry policy and you affect load. You add a cache, then you change traffic load. You change traffic flow. You shift team ownership, you change the pace of delivery. Each change creates new patterns. Some stable, some not. Every dynamic system is shaped by feedback loops. Reinforcing loops, sometimes called positive loops, amplify change. Balancing loops or negative loops counteract the change and push the system back into an equilibrium. Meadows thought that once you see patterns like this, you start to see where small, well-placed changes might shift the overall system's behavior. Donella wrote a paper, it's called Leverage Point, Places to Intervene in a System, where she put all of these things together. There's some words that we know from computer science on a daily basis, positive and negative feedback loops, but you really should read this paper. Call this homework. Yeah? Come up, take a picture of the QR code, and that's your homework for the coming week. Yeah? The Renaissance developer thinks in systems. And to build resilient systems, you need to understand the bigger picture. If I think about a third quality of the Renaissance developer, is communication. He, she communicates. Yeah? And if you step into this broader view, you realize that the ability to express your thinking clearly is just as critical as the thinking itself. And this is why I believe that one of the most important things that an engineer or a technical leader can do for their career is to practice, develop strong communication skills. Let me give you an example. Let's go back 2 years when we did the Frugal Architect. Don't know if you remember this picture. This is the Amazon homepage. And then I explained to you how we had divided that homepage or the overall Amazon system into 3 different tiers. Tier 1 is something that is absolutely necessary to make the system work. Search, browse, shopping cart, checkout, and reviews. Without those 5 things, the site doesn't work. Tier 1. Tier 2 are things that are important to our customers. Personalization, recommendations, things like that. And tier 3 might be nice to have kind of parts. To be able to do this is important not just for us as engineers, but as communication tools towards the business. You go and sit around the table with the business and talk about how many nines available does tier 1 need to be? Oh, 4 nines. That will cost you that much. Yeah? Or tier 2, maybe 3 nines. Yeah? Tier 3, Maybe you don't care at all, 2 nines. Or you think, well, we'll do a manual failover if the data center goes offline. But it's a communication that you need to have. You need to be able to clearly describe your system and the capabilities and the opportunities towards the business. Communication is crucial. Now, human languages, it's a bit of a challenge, isn't it? Yeah? Although, because natural language is ambiguous. Yeah? But we have so many different senses at the same time, that we can turn this natural language into something less ambiguous. Do we put grammar on the grill? Or are we having dinner tonight? Yeah? Even without a comma, you probably already have figured this one out. Yeah? Now, we've always communicated to machines through programming languages because they were precise. We could precisely indicate to the machine what we wanted it to do. Yeah. But in today's world of AI-assisted coding, we increasingly communicate with the machine in natural language, which is ambiguous. So we need to help to develop mechanisms to reduce the ambiguity of that language. And reduce the ambiguity of the human such that a machine can create logic. Yeah? Specifications reduce ambiguity. And our history is rife with stories of spec-driven development. Dijkstra's structured programming environment before it was based on formal specifications, but that proved program correctness before you even implemented it. The Apollo guidance system relied on meticulous specifications that guided its 145,000 lines of code, a blueprint so precise that it helped land people on the moon. And to talk more to you about specifications, I'd like to welcome Claire Legiori, Senior Principal Developer on the Keynote team. Claire, up to you.
Thank you, Werner. Sometime last year, I started noticing that as I was vibe coding more and more, I had a communication problem. I was spending more and more time trying to describe to the AI what I wanted. The code that the AI generated was good, but the end software didn't do what I wanted it to do. I would often try to start over with a new prompt and start all over again and try again. I noticed that over time, I wrote longer and longer, more detailed prompts, trying to define what the software should do. I would write these long, detailed prompts in Obsidian and Markdown, and then I would copy and paste it over to my coding assistant. I was essentially creating a specification to better communicate with the AI what I wanted. Software specifications can clearly communicate how a system should behave, what it should and shouldn't do. And like Werner said, many systems in history have been based on specifications, like Apollo missions. It felt like specifications were exactly what was missing from my interactions with my coding assistant. But then I thought, how could we use this idea of specs as prompts? What would spec-driven development look like? And this spark of an idea led us to start work on the Kiro IDE. With this idea, though, we now had a new communication challenge. How can we communicate and validate this idea with potential users? We didn't know what it would look like, and we didn't know what users wanted. It was also kind of difficult to describe what spec-driven development was. They hadn't seen it before, and we hadn't built it yet. One of the best ways to get your ideas across is to quickly build a prototype, something that your users can see and touch. Rapid prototyping is, of course, not a new idea. Let's go back to the 60s, to the time of punch cards. In 1964, Doug Engelbart at SRI had a rough idea for a device that had wheels on the bottom, and you would slide it across a tabletop to point to something on a computer screen. And we can probably all picture this device in our head, but can you imagine going back to the 60s and trying to describe what a mouse is to this guy? Engelbart's team rapidly built a prototype out of a block of wood. It was a wooden shell, it had wheels on the bottom and a button on top. And this rough prototype communicated better what a mouse was, better than any drawing or description could have. It let people put their hands on it and get the concept immediately. It had great ergonomics. It felt great in their hands. And like the mouse, rapid prototyping was crucial for Kiro. We knew that the ergonomics of spec-driven development was going to be important, how it felt in the hands of a developer. We rapidly built prototypes of how we thought spec-driven development could work. And we put those prototypes in the hands of some internal users, and we asked them to use Kiro every day. That was going to be the best way for us to understand what felt good and what didn't feel good. This is a great example of what AI can do for us now. AI has fundamentally enabled rapid prototyping for software. I'm sure that in the past, we've all spent months manually coding a single idea. And now we can give our users real working prototypes in minutes to get feedback about what feels right. Rapidly prototyping Kiro even let us use Kiro to build Kiro. Our very first prototype of the Kiro IDE could only do vibe coding, but from that moment on, we were able to use the Kiro IDE to generate the code for the Kiro IDE. And by using the Kiro IDE to build out the product, we were able to iterate through many ideas of how spec-driven development could work. One idea was test-driven development specs, taking inspiration from TDD techniques. You would describe a change that you wanted, and Kiro would generate tests to validate the behavior that you described. Kiro would then generate application code and made sure that it passed those tests. But we found that developers couldn't always capture the nuance of what they wanted their software to do or look like with tests only. We tried out traditional technical specifications, similar to those that Werner described for the Apollo guidance system. They described the system as a whole and each component in detail. With this, you'd add a new feature to the overall spec, and Kiro would kick off coding tasks based on the changes that you described. These specs were great context for the AI and even for developers who weren't very familiar with this code base. But for real-world projects, they sometimes became overwhelmingly long. So it was difficult to figure out where in this long spec you should put your changes for your new feature. We took a step back and we looked at how we already worked as a team. When we had a new feature idea, we would describe it, we would work through product requirements, review a design doc, and create sprint tasks. And we thought that perhaps specs could follow this same pattern, and that became feature-driven specs. We separated the flow into 3 documents: requirements, designs, and tasks. And we found that this gave developers more control over the AI and let them better communicate what they wanted. All of these rapid prototypes gave us critical user feedback that led to today's spec-driven development workflow that's in the Kiro IDE. With a spec workflow now in place in Kiro, we could use it more effectively to keep building out the product, because now we could communicate more precisely with the AI what we wanted. Often with vibe coding, I find that we give these very ambiguous tasks to the AI. We might say, build me a web trivia game. And out of this very short prompt, there's probably a million possible different final outcomes. But probably only one of those is what you have in your head. With vibe coding, the AI is going to take its best guess as to what you meant, and it'll generate code. But that leaves you to iterate on the code with the AI instead of on what you originally meant. With spec-driven development, you have an opportunity to refine what you mean more precisely through specs. You can give the Kiro IDE that same ambiguous task, but instead of jumping into the code right away, it's going to first generate requirements, designs, tasks. And if those don't match what's in your head, you have the opportunity to ask Kiro to change it and refine it. Let's walk through a real example of a production feature that we built in the Kiro IDE using spec-driven development, system notifications. We started here with a little annoyance that we ourselves experienced with an early version of the Kiro IDE. Agents can take a while to complete their coding work, and meanwhile, we would switch away to a different app. But then the agent would need user input, or it would complete its work, and we would have no idea that it was sitting there idle while we were away doing other work. So we set out to build a feature that would notify the user when the agent needed its attention. We started by having Kiro generate a spec, and the generated requirements actually helped us to think through some details, like which agent actions should trigger notifications to the user. When we got to the design phase, we'd expected this to be a pretty simple integration into the Kiro agent code, but instead, Kiro generated this very complex design that would build an entirely new notification system directly in our agent code. Now, if we had vibe coded this, we would have ended up with a lot of code that we didn't actually want. But instead, the spec process helped us quickly realize this was a much bigger project than we originally thought. We iterated on the spec to first focus on building a notification system directly outside of the agent code and directly in the underlying IDE code. This needed to be built on top of Electron's native notification API. Kiro IDE is based on Code OSS, which is a code base that spans 10 years of development and 2 million lines of code. It can be difficult for any developer to figure out where they need to make changes in this code base. But Kiro's spec workflow actually helped us to explore and understand where these changes needed to be made. And once these changes were in place, we were again able to use spec-driven development to integrate it into our agent code. Throughout this project, we were able to quickly iterate on our specs till we got exactly what we wanted from the AI. With spec-driven development, we shipped this agent in roughly half the time as if we had vibe coded it. In our experience building Kiro, we realized that AI has changed how we communicate and how fast we can iterate. We can iterate on the software design by communicating with the AI through specs. And we can iterate on what the software does by putting real working applications fast into our users' hands and get feedback. AI and spec-driven development helped us to build a better Kiro IDE. And this was in large part due to more precise communication with our users through rapid prototypes and with AI through specs. Natural language doesn't have to mean high ambiguity. And personally, this is what I think makes Kiro IDE so special. Kiro IDE brings precision to natural language. And with that, I'll hand it back over to Werner.
Thanks, Claire. Communication is so important that Claire shows. It leads to systems that have fewer mistakes. Actually, let me tell you a story again, sort of out of my own youth. When I went to computer science school, there was a class called interview technique. And I go, what? Interviews, because you think about journalists and things like that? No, it was how to learn to talk to your customer, to really trying to understand what he or she actually really wanted. Because they may come to you already with a technology solution without knowing anything about technology. Wouldn't be the first time these days when I meet a customer who says, what should I be doing with Gen AI? And then, because you're really trained in trying to figure out into depth, say, I very apologize to answer your question with a question, but why are you asking me this? Most of this is fear of missing out. And so really diving into it, with the customer to understand what's the problem they want to solve, what's the opportunity that they see. All of that is communication that we as engineers should have. Now, let's go to the fourth, what I call the fourth quality of the Renaissance developer. Yeah, the developer is an owner. Ownership. I've spoken about it before, but today I want to focus on one part of it. Owning the quality of your software. AI will let us build things bigger, systems, explore more ideas, move faster than ever before. These tools will, as the modern-day philosophers Daft Punk once said, help us build harder, better, faster, and stronger. And if we use these tools correctly, they can help us produce high-quality software. But there is a risk in how some developers are starting to use these tools. Vibe coding is fine, but only if you pay close attention to what is being built. We can't just pull a lever on your IDE and hope that something good comes out. That's not software engineering, that's gambling. And you need to be out there somewhere for that. Yeah? Remember what I said at the beginning. The work is yours, not the tools. If you're subject to regulatory requirements, let's say healthcare, financial services, and whatever, if AI creates some code that suddenly violates the regulatory requirement, you can't go to the regulator and say, oh, it was AI. No, it's still your responsibility. The work is yours, not that of the tools. Now, the world is changing. You will write less code. Because generation is so fast, you will review more code because understanding it takes time. And when you write the code yourself, comprehension comes with the act of creation. When the machine writes it, you will have to rebuild that comprehension during review. That's what's called verification depth. And it's one of the two main challenges that I hear when I speak with developers about this new style of work. AI can generate code faster than you can understand it. Code arrives instantly, but comprehension does not. That gap allows software to move towards production before anyone has truly validated what it actually does. The second challenge, of course, is hallucination. Claire showed already a perfect example of that earlier. The model produced a design that looked confident, but was completely wrong for the architecture. Some APIs change and LLMs invent attributes that do not exist. Sometimes they propose solutions that are completely inappropriate or over-engineered or ignore your system's own patterns. These outputs look plausible, but they're not grounded in reality. I think we're making progress there. Yeah? We're developing practices that, like spec-driven development, which Claire showed how it can dramatically improve quality. Byron, in Swami's keynote, showed how tools like Cairo can actually use automatic reasoning with your specification to create code that is verified. He showed how we can also use automatic reasoning to ensure that code generated against AWS APIs is correct. I also see many developers looking at their CI/CD pipelines and building more and more automatic testing. Yeah? These are all types of mechanisms. Here, I want to make a change. Yeah, I want you to really understand these two things. There are mechanisms and there are good intentions. They're not the same. And let me do that by, again, going back a little bit in the past, and tell you a story about Jeff Bezos. In the early days of Amazon, we as executives were required each year to spend 2 days with customer service and take calls from customers, such that we would truly understand what our customers were going through. And not just us lowly executives, Jeff himself as well. So Jeff sits next to this customer service agent, phone goes, and automatic system already spits up what the order histories of this customer. And before that the customer says anything, the customer agent says to Jeff, she's going to return that table. And indeed, the customer wants to return the table because it's damaged. Call is over, and Jeff looks at the agent and says, how did you know that? She says, well, 70% of those tables are coming back because there's some drop shipper that actually doesn't really know how to package them right. Of course, Jeff gets everybody in the room and starts to think about everybody has good intentions. No, of course we don't want this to happen. But without a mechanism, nothing changed because everybody already has good intentions. So he introduced a new mechanism, Amazon's version of Toyota's famous Anden cord. So the Anden cord in Toyota the principle was no car should leave the production line with a known defect. And then any engineer working on the line could pull this cord and bring the whole manufacturing line to a standstill until the defect was fixed. The Anden cord that the customer service agents got was a button to make the product unbuyable. That made alarms go off with the people that were responsible for the products to go and fix it. But, before this, everybody already had good intentions. But until we introduced the mechanism, nothing changed. Yeah? Now, let's go back to our technology world. Mechanisms take many forms. Each team builds their own one that fits the scale and the nature of their work. The S3 team, for example, uses something which they call durability reviews. When an engineer proposes a change that might touch durability, they pause and model the risks. They write down the changes, they list every threat imaginable, map out the guardrails to keep the data safe, and it's a mechanism with a very powerful effect. It turns durability from a property of code into the habit of the organization. It makes engineers think in failure modes, not happy paths. And it shows why mechanisms matter. They convert good intentions into consistent outcomes. Now, if you think about it, code reviews are also a mechanism. And I know it. We all hate code reviews. It's like being 12-year-old and standing in front of the class. Yeah? But they're a very important mechanism because they create a moment where intent and implementation meet, where another engineer can question assumptions and catch things that the author no longer sees. In an AI-driven world, they matter more than ever. In an AI-driven world, they are crucial. Models can generate code faster than we can understand it. So the review becomes the control point to restore balance. It is where we bring human judgment back into the loop and make sure that the software actually does what we expect it to do. I encourage all of you to continue and you increase your human-to-human code reviews. When senior and junior engineers work through code together, it becomes one of the most effective learning mechanisms we have. Seniors bring pattern recognition and hard-earned judgment. Juniors bring fresh eyes and often spot details others overlook. This is how we transfer knowledge and how we grow the next generation of builders. AI will change many things, but the craft is still learned person to person. So the fourth quality, in my eyes, of the Renaissance developer is an owner. You build it, you own it. The last quality that I want to talk to you about is that I think you, the future Renaissance developers, need to become a polymath. Now, it has nothing to do with math, by the way. Yeah? It's not mathematics or maths or whatever you want to call it. It actually, the word polymath has nothing to do with that. It actually means many, because it comes from, the math comes from the Greek word mathanion, which means to learn. It's about having deep domain experience, but also have knowledge that spans many different subjects. Da Vinci probably was the absolute best example of a polymath because he worked across so many different disciplines. He was a painter, he was an engineer, he was an anatomist, and he was an inventor. Yeah? Now, I do not expect you all to become a Da Vinci. Yeah? But you should expand your knowledge just beyond deep domain expertise. Yeah? This is what I would call an I developer. An I-shaped developer is someone who is really deep and really highly specialized in one area. Let me tell you, again, an interesting story out of my own experience. This is my old mentor and friend, Jim Gray. And Jim got the Turing Award because actually you should all know Jim Gray because he's the inventor of transactions. Every transaction you do today, we have Jim to think for this. But he also had this great mind. He was interested in so many more things than just databases. And this is one of his famous sort of challenges. Give me 20 questions, 20 important questions that you want to ask of your data, and I will design the system for you. One of the first ones he worked on was the Sloan Digital Sky Survey. This was one of the first massive data sets that were out there. It was groundbreaking work in developing the Sky Server. Jim's in-depth knowledge as a database expert was transformative for the computation in astronomy data. There's actually a really funny story about that. At some moment, Jim goes to Baltimore, where the group is, and he walks into the server room. 30 seconds later, he walks out, and he tells them that their database layout is wrong. And everybody looks at him and says, how do you know that? By just listening to the rattling of the disks, he knew that there was way too much random access. His intuition, built from decades of experience, had given him a sixth sense of how systems should behave. He advised him to redesign their architecture, and performance improved dramatically. Now, Jim wasn't what I would call an I-shaped developer at all. His curiosity reached far beyond databases. He understood people, he understood business, and he understood a wide range of technologies. And like great technologists, I will describe him as T-shaped. Deep in one domain, but broad in understanding. The skills you need to be successful in your job are a unique mix of personal skills, functional depth, industry knowledge. A database developer who understands front-end performance or cost-aware architectures can make a better architectural choices because they see how their work shapes the overall system. That breadth of knowledge gives you the perspective to improve what you build because you understand the trade-offs. T-shaped developers combine depth with breadth. They can dive deep into specific problems, but will also understand how it fits into a larger system. That is my advice to all of you. Build both. Develop depth in your domain, but cultivate a range to connect to multiple disciplines and ideas. So the last takeaway from the Renaissance developer is become a polymath. Well, I don't expect you all to become that, but you should broaden your T. Great developers are T-shaped. They're experts in their field who understand their work fits into a larger system. You must broaden your T. Now, if we look at sort of the Renaissance developer, throughout this talk I've called them different ways. I think you need to be curious and keep learning. Think in systems. Communicate with precision. Be an owner. If you build it, you own it. And finally, become a polymath. Expand your knowledge. Then you'll have plenty of time next week to start putting all of this into practice. But for tonight, join me at the Las Vegas Festival grounds. There'll be great food, some crazy games, and of course, live music headlined by Beck and Cascade. It's a chance to celebrate with your teams and unwind after a week of serious learning and building. Now, there's one more thing. I want you to leave here with this. When you build something like an app, do you customers ever thought about all the work that goes underneath there? An Amazon customer will click a button and the package arrives. Does it think about the people that actually maintain the catalog? That do the supply chain? All of that work? Nobody sees that. Your customers are never going to tell you that your database engineers are doing amazing work and they love what they've done. Only you understand that work that goes into it. I believe it is important for all of us to have pride in our work, in the unseen systems that stay up for the night, in clean deployments, the rollbacks that nobody notices. Most of what we build, nobody will ever see. And the only reason why we do this well is our own professional pride in operational excellence. That is what defines the best builders. They do the things properly, even when nobody's watching. And when I look at the work that you deliver every day, I see that commitment everywhere. So for that, I am immensely proud of you. Thank you for all that you do. Two more. Two more words. Werner, out!